Hi class, today we're going to talk about dividing fractions, and in order to divide fractions we need to find the reciprocal of a fraction. So that's what we're going to start with first. I'm on page 10 in our notes. So if we look at the top, reciprocal is the inverse of a fraction. You get a reciprocal by flipping the fraction over. So if we look at our example, we had 1/9. If we take the reciprocal of 1/9, we end up with 9/1. So let's find the reciprocal for each of these three examples that we have on this page. So it says directions, find the reciprocal for each fraction below. It says if it's just a fraction, flip it over. So if I have 2/5 and I want the reciprocal is going to be 5/2. Now, if it's a mixed number, we need to convert it to an improper fraction first and then flip it over. So we do the magic C, multiply the bottom, add at the top. 4 times 3 is 12, plus 1 more gives me 13/4. And I can take the reciprocal of that now, and I can have 4/13. The last one, it says if it's a whole number, make the denominator 1 and then flip it over. Remember, when there's a whole number all by itself, he's lonely, you give them that denominator of 1. Remember, 1 is the loneliest number. So 1 has to go underneath lonely whole numbers. And then I do the reciprocal, which is 1/7. So what you need to do is if you need to, watch this part of the video again. And then you can try numbers 1 through 9 at the bottom of the page right here. And you can pause the video, try those now, and then once you are ready, unpause and I'll have the answers there for you. Okay, here are your answers. Go ahead and check your work. If you need to pause the video before I go to the next slide, go ahead. On the next page, on page 11, we're actually talking about how do we divide fractions. So, in order to divide fractions, we need to convert all mixed numbers into improper fractions if there are any. Just like we did with multiplication, we need to do the same thing with division. So in this example, I have a mixed number here, so I need to turn it into the improper fraction by doing the magic C. So when I do the magic C, I'm now going to have 3/4 divided by 3 times 1 is 3, plus 1 gives you 4/3. Now, this is where division gets different than multiplication. Because if you think about dividing up a fraction, it can get kind of messy because you're taking a fraction and then you're dividing it into pieces, and then it just doesn't make any sense. So what we do is we do keep, switch, flip. We use that reciprocal, and instead of dividing up the fraction, we multiply. So we always write KSF underneath our fraction. The K means keep the first fraction the same. We keep the first fraction the same. The S means switch the sign to multiplication. So I'm switching that division sign to multiplication. And then number 3, the flip, I flip the second fraction over. So I do the reciprocal, or you could think of it as a refliprocal if you need to remember that to flip over the fraction. So when you do that, you now have 3/4. We switch to multiply, and then we flip the second fraction over. It was 4/3. I do the reciprocal, it becomes 3/4. I go across the top, and then I go across the bottom. 3 times 3 is 9. 4 times 4 is 16. Now I have to ask myself, does this simplify? Well, they don't. They are not both even. They don't end in 5 or 0, and they both don't divide by 3. So 9/16 would be my final answer. You could also see if 9 goes into 16, and you could get a whole number out, but 9 doesn't go into 16, so it's not going to work. So let's look at these 3 examples together. I have division. I don't have any mixed numbers, so I don't need to do any improper fractions. So I'm just going to do keep, switch, flip. It's nice to get in the habit of writing the letters underneath so that you are paying attention whenever you are seeing the difference between multiplication and division. So I'm going to keep the first fraction the same. I'm going to switch to multiply, and I'm going to flip the second fraction over, so it becomes 7/2. Then I go across the top and across the bottom. When I do that, I get 28 across the top, and 7 times 2 is 14. Now, because I have a larger number in the numerator, that means there's a whole number hidden in that fraction. So if I use my calculator, I use my brain, either one, 28 divided by 14 actually just gives me a whole number of 2 for my final answer. So I don't have a fraction answer, I just have a whole number of 2. Now if we look at example number 2, I have a fraction divided by a lonely whole number. He's so sad. He needs the buddy 1 to go underneath. Alright, so I have a division problem. I need to do keep, switch, flip. Keep the first fraction the same. Switch to multiply. Flip the second fraction over. Now I multiply across the top, multiply across the bottom. 3 times 1 is 3. 5 times 4 is 20. Are they both even? No. Do they both end in 5 or 0? No, only the 20 does. Do they both divide by 3? No, and 3 doesn't divide into 20, so my answer is 3 over 20. Now if we look at our last example, number 3, we have mixed numbers, so we need to turn them first into improper fractions, multiplying at the bottom, adding at the top with the magic C. So if we do the first one, and I'm just going to write this out so I have my spaces all set up already. 4 times 2 is 8 plus 3 more gives me 11 over 4 divided by 3 times 5 is 15 plus 2 more gives me 17 over 3. Now I don't want to divide fractions, so I'm going to do keep, switch, flip. I have 11 over 4 times 3 over 17 equals, now remember I go across the top and then I go across the bottom. 11 times 3 is 33 and 4 times 17 is 68. Then I ask myself, are they both even? No. Do they both end in 5 or 0? No. Can they both divide by 3? No, and 33 doesn't divide by 68, so that is my final answer. Okay, so your job is to go through the rest of the notes pages for this section, and once you finish, you're welcome to check it against the key on the website.